Welcome back to Create. This is GB. I've got a workbench video for you guys. We're going to talk about how to troubleshoot and repair things that you don't have a schematic for or really any information for. This is a CGA arcade monitor. It actually came out of a Moon Patrol, and it's kind of a strange monitor. My customer doesn't really know what's wrong with it, and I've looked for a schematic and I'm not going to find one. So we're going to have to troubleshoot this thing on our own. So the first thing you need to do when you're trying to fix anything is figure out or clearly define what it's not doing, and if it's doing anything strange, also clearly define that. So let's go ahead and get this thing turned on. Okay, the first thing that I noticed that the DGOS coil, I heard the thump, and that means that it got power. It also means that we're getting some power into the unit. Having a look at the fuse, it appears to not be blown. I don't hear any noises. If I run my hand over the front of the screen, I'm not getting any high voltage. My heater coils are not turning on. I'm not getting any glow at the back of the CRT. Okay, so we're going to start to talk about how we figure out what's wrong with this thing. So first we just write down all the things that we noticed. We didn't see a picture or a flash when we turned the unit on. I didn't notice any high voltage or static on the screen. There's no glow in the tube. And then when I turned the unit back off, I didn't see a flash as well. I didn't notice any smoke. And really no sound other than the DGOS coil. But it was a thump sound, so we'll write down that we heard a thump sound. The next thing, we write down the things that we know are working. So I'm pretty sure that the DGOS coil is working, because I've worked on enough computer monitors, watched enough television to know what that thump is. And then we write down anything else that we think is weird, that we've never seen before or that we would not expect. Now on this particular project, I didn't really see anything that was out of the ordinary. So using this information, we're going to start to think about how the television or how the monitor works itself. The next step is to gather any information you can get about the device that you're repairing. And then as you develop an understanding of how it works, you draw up a kind of a flowchart or a block diagram of how you believe that this particular device behaves, and then try to eliminate systems that you don't need to worry about, or that and that'll help you clearly identify what you need to do first, or to address or test first. And if we look at our list of things that we noticed and were working, the DGOS coil we do believe is working, so we think we've got AC input. But our high voltage, I didn't notice any static on the screen. My tube wasn't glowing. So I think I can go ahead and cross out the filament, because I believe that those things are not working. And that points at this flyback circuit. This thing could be our high voltage shutdown. The high voltage shutdown, I've learned from the past, is usually related to something else going wrong in this circuit. There's not a good way to test the flyback, so I'll keep working my systems backwards until I find one that's easy to test. So we'll look at the horizontal drive circuit here in a minute. That's a key that's a key worry of mine in this problem. Um, Also, if we're not getting power to the horizontal drive circuit, it won't work either. And it comes from this area over here after the AC input. So the next two things that we need to test are the horizontal drive circuit and make sure it's getting the power it is supposed to get. And if not, we can work it back through the power supply here. And like I said, this is a very important thing to do. Whether you can find a block diagram of a common monitor or a common block diagram of whatever you're working on the internet, or if you have to draw one up yourself, this really helps you narrow down what you need to look at. So to identify the voltage at the horizontal output transistor, the first thing we need to do is identify what our ground is. And I've already turned the system off and discharged all my large capacitors through a resistor. So the first thing I do to identify ground is I usually look at the power supply as it comes in, and then identify the largest filter capacitor, which is this one here. And so we'll go ahead and test and make sure. So the one with the most connections is usually ground. So, and it's also the negative side of the capacitor. You can look at the top of the board and determine the negative side of the filter capacitor is here. However, that's usually how you find your ground. However, in this particular case, it is not. The ground is actually the chassis, which is pretty common. So what you do is you go ahead and you continue looking around for things that their negative components attached to. And you can see that this part right here is indeed the main ground. And these are not connected to each other. So this is my normal method, but in this case it was wrong. So I continued to look and see if that was connected to any of the other major grounds throughout the circuit. And it turned out that this was the ground, and they floated this ground. So this is going to be our main ground, and it turns out that it is shorted to the chassis. So we know that we can use the chassis for ground. The next thing we need to do is identify the voltage on the horizontal output transistor. So I'll make sure that that is that checks good there. And then we will go ahead and turn this over to, and we're looking for DC, so we'll put it on DC volts. I'll go ahead and turn the chassis on. Make sure I'm not touching anything important here. Go ahead and turn my chassis on. And this is the horizontal output transistor. I've already identified that this is ground. I have no volts there. This is the base of the transistor. I have 0.6 volts there. And then I have 0 volts exactly on the collector of the horizontal output transistor. And what that tells me that somewhere in this power supply it is shorted to ground. So the next thing I need to do is turn this chassis off. Turn this chassis off and discharge my large capacitors. So now I need to determine why our horizontal output power supply is shorted to ground, and I'm going to verify that here with the continuity tester. So this is our ground, and that is ground, and I'm going to check and make sure that our ohm reading isn't anything weird, because sometimes anything under 20 ohms will read as a short, and it's supposed to be there. So between ground and the chassis I have 0.5 ohms and 0.5 ohms, so that's grounded together. So more than likely this transistor is bad. So I'm going to go ahead and pull that out. And then we're going to retest and see if our voltage has returned or if we need to continue working backwards through the circuit. Thing we've got to do now that we've removed the short, we're going to determine if the voltage has returned now that we've removed the short out of this circuit. So I've got ground here. I'm going to put no. So whatever is supplying the B plus voltage has been killed by this short. And the reason that I know that this was the primary problem is that it is the most common problem in a computer monitor or a arcade monitor, and it was also the closest to ground. We know that that right there is ground, and so very rarely will you have anything die way up here at close to say 170 volts that will kill something all the way down here right next to ground voltage. So I believe that this was the culprit. So secondly, we've got to figure out where the voltage stops being supplied to this transistor. So if we trace this contact backwards, it goes to the flyback and then works its way up. That's 1 volt. Okay, and all I'm doing is just randomly testing these leads and seeing if I can find anything that makes sense to me. I'm not really finding any significant voltage or power supply. So the next thing I want to specifically check is when you do your research, you find that the power supplied to the horizontal output transistor usually goes through the flyback transformer, and it's supplied through a giant resistor usually, and this is resistor right here. So basically what we needed to do was trace it back to this resistor, and we have done that, and we get 1.3 volts, 1.3 volts, 1.3 volts. That's not really any significant voltage. Also, I know that since the voltage rating is 1.5 volts and 1.5 volts on either side of this resistor, that this resistor is not supplying any power to anything. So it looks like I got my problem out of the circuit down here by taking this out. So I'm still tracing it back. 1.3 volts. Now this is the jumper wire that brings it over, the power over from the power supply. Still not getting anything. Oh, there we got something. 99 volts. Okay, see that 99 volts? That's a weird number for me, because I would be expecting to see 170 volts or maybe half of that. And the reason 170 volts is so common is that is what 120 volts AC rectifies to, not under load. So keep looking here. Not getting anything. And what this is telling me is that these components are probably okay. Ooh, there's 50 volts. It's also a weird number. Let's see. We're tracing that back to... Okay, we got 99 volts, and that is the top of that capacitor. So if I do this, I should get 170. Okay, so the reason that I got that 90 volts is because this is floating, and I don't have a... There's obviously a resistor or something in between this ground and this ground, and I'm getting... Okay, so 99 volts. So we are now... What that tells me is I should now be testing with using this ground, because we've gotten across the float. And they probably they probably cut the they floated everything on this side of the transformer here. So I'm going to start using this ground, 170, 170, and work this direction, because this is obviously my power transformer. I'm going to start working. I got 170, 170 goes into that. Should come out there. 6.6 volts. I got a diode dropped here. So that should be 0.6 volts. That looks good. If I go to here, it should be a little less than. Okay. So it looks like I'm getting power to this IC here. Yeah, I'm definitely getting 170 volts to this IC. Okay, so I think we've narrowed it down. I believe that when this horizontal output transistor failed, it shorted the output and drew too much power from this circuitry here. So my next step, this IC here, which is the power converter IC, is obviously dead. So I'm going to have to take it out and test it, and then I'll test this circuit all by itself. And it looks like I'm not going to have to draw anything up for this this test today. So let me go ahead and pull that out, and we'll see where we go from there. So here's the voltage regulator that we pulled out. It was such a pain to replace that I didn't film any of it. But anyway, I've replaced that. It was too difficult to test, but we knew that it was dead anyway because it wouldn't put any power out, and the rest of the circuit was working properly. And we'll go ahead and fit in the new horizontal output transistor. And I like to fit them in here from the bottom because it's easier. So make sure it fits. So we'll go ahead and put that in. Thermal grease there. Go ahead and turn my variac on and bring it up slow. Using the component tester, I'm used to seeing something that looks like this for a capacitor. And this component, when I tested it, looked like this. Now, there's a couple things here that are important. One, when I was testing it, it was shifting badly back and forth, which would indicate that I was getting some weird voltage shifts within the capacitor. Also, there's a resistive angle to it. A resistor looks like, let's see if I can grab one. A resistor looks like this. And a 10K resistor looks a lot like this. So if you'll notice, when I test my errant capacitor here, I do get an angle there. From this point to this point, I'm getting the angle. So that's telling me it is conducting some current that is DC. Now, I went ahead and got a replacement. And this is what a good one looks like. I do get a little wiggle here. That's just, I really don't know what that is, but it's okay. But what I'm concerned about is that it's even right here. So we'll go ahead and replace that. It's all put back together, and I've got my signal generator going, and let's see if it powers up. like we got high voltage. Got a heater. Great. Looks like we got some sync issues. Now we are working on getting our horizontal and vertical sync figured out. There we go. My signals were also inverted. So next thing we need to do is start working on our colors.